You got, well, we have to check it, right? We have to make sure that, the data is coming out of there is correct. And like I say, these guys, they kind of don't know exactly what to do. And I think we should just do what we know we should do, right? And they'll be okay with it. But that's going to be, we'll start with the list that Mike's got from Martin County. And we'll take the best quality wells. We need to do some data cross-referencing, right? So we need to make some maps and stuff, right? Like where are all these things at? Okay. Which ones have good logs, right? And then which ones have lots of core? So then we take the wells with the good logs and lots of core, and we load that data into IP, we depth shift it, and we get everything aligned properly, right? And then after we get there, then they can worry about how they're going to convert these facies to whatever, right? Like I'm not really concerned about that part of it. I think what we do is we just load the Core Lab stuff as is into IP, right directly from the WellCat files. And we can always go in there later and run whatever algorithm we want to convert those to some other facies, right? Some of it are what? Oh, there's nothing in the file. Yeah, that's possible, right? The reason for that is probably because the file types are different or something, or it was stored differently, and the script missed it. So what we'll just have to make a list of the files that fail, and then go back and have a second look at those ones, right? Because that's typically what happens with some of this stuff too. Is there's they're constantly updating that program. So depending on whenever the file was created, it may not have been opened in a newer version. And whatever I did there with that Python script, which I used Claude, right, to help me with that. It's kind of just digging around in those OLE files looking for stuff. And there's no real, master architecture to the file. It all depends on what was available and what they put in. Like some of them got logs, some of them don't have logs, some of them have gamma ray, some of them don't, some of them have resistivity, some of them don't, some of them have tops, some of them don't, right? So it all depends. And then, whatever the file was created with, that defines the structure of it. So then, we're missing things like they may even be in there, but that's like I say, we take a short list first, we get everything out of it, and we spot check it, right? So you've got the WellCAD free reader installed, I assume, right? Open the file, look at the data, make sure that it's correct, and then after we've convinced ourselves of that, then it's just a matter of getting it in IP and building an IP database around this. So we'll have to find all the wells. We need like an Excel sheet, right, with all the API numbers, and then I'll show you how to here. I'll send you a chat message here. If you don't have this, install it now. It's called LinkPad. It's a SQL query tool, and yeah, and so what I've got is a piece of code that I run that builds SQL databases from IP, so that we can extract everything, all the curve names, the well names, and we can search it then, right? We can search by API number, we can search by curve. So we can find all the wells that essentially cross-reference with what we have from this these WellCAD files. And then we'll see what we're missing, right? We'll be able to make these different sets and stuff and say, okay, here's all the wells we got. Here's the ones that we have logs for. Here's the ones we don't have logs for. Yeah, and then on top of that, because these are part of the Core Lab 4 consortium, right? Like when I just downloaded the WellCat files for these wells. But if you go look on the client's server, they've got the entire data set. And the entire data sets include a lot of core data that are in Excel sheets and stuff and logs. So we may even have a lot of this. Now I do know specifically that the majority of these wells, at least like 110 of them or something, or 120, are from the Core Lab Tight Oil Consortia, which was like, I remember these things. I'm that old, right? Like and it wasn't that long ago, but like I remember when we started that consortia back in 2012 or whatever it was. And I was going to the meetings and stuff, you know. So what how these things started was people wanted to know more about these unconventional shales, and the companies didn't want to spend, you know, hundreds of millions of dollars on core analysis and cutting core. So they joined the consortia. Everybody contributes core to it, right? Like every company, and then you group together and share the data. So like you end up with 100 wells, right? But in order to join, you have to give. You don't get in for free, right? So you got to give a couple of cores to join the consortium. So, like, I remember when all this stuff went down, and the majority of these are going to be part of that. And I've got an IP database sitting around somewhere that's got all of the well logs from every well that was part of the Tight Oil Consortium. So we should have most of the basic logs. We may be missing some of the advanced ones. We'll need to load those, like they're talking about, right, like image logs and NMR and stuff like that. And then some of the core data may be in there, may be missing, right? Where we can go back out on the network and actually find some of that core data. So long story short, you know, like I told these guys in the meeting, we need to high grade to your favorite 15 to 20 wells. And we start there. And once we get the IP database wells all figured out, then what we do is we go in there, we load this data that's getting exported from the WellCat files, we depth shift it, make sure that it's on depth, right? And then we can start doing correlation and analytics work, right, after that. Even if we have to export it back out of IP into something else like Spotfire or whatever, right? You want to use one of these data analytics dashboards with Python, I don't care, right? It doesn't make a difference. But IP, the whole reason we'd be using it is to produce a database that's got all the log, core, and WellCat data in it. Be able to depth shift and do what we need to do with it. So yeah, start playing. You know, create some spreadsheets if you can of the data inventory. Right, which wells passed, which wells failed, so forth and so on. API numbers if you can get them, and then I'll send you a SQL database of the IP project that I've got, the main one that's got like 5,000 wells in it, and I'll show you how to open that and query it, and then we could start doing a little bit of you know, table joins and inner joins and outer joins and whatever the hell we need to do to figure out what we've got, what we're missing, and we'll deliver that to the client, to the customer, right? We'll tell Corey and Mike and all those guys, here's what we found, here's where you're at for the moment. Which wells out of that list, right, that we have logs for, do you want to look at in detail? And then we'll narrow that down. I suspect, and I'm just guessing, right? But I suspect that we'll probably have like 75 or 80 wells that we have logs for, and we have the WellCat files for. And then out of that 70 or 80 wells, I think 20 is a good starting point, you know, to kind of get into and start doing some analytics work on. And then once they figure out, okay, this is how we want to convert the 35 lithofaces from Core Lab to whatever, the 6 that they have, right? Then that's when you start doing the machine learning. where you would actually start to train to that using different models and see what works and what doesn't. And you know, we've got that machine learning study that we need to finish too. That's been on the back burner for like 6 months now. And you know, part of that is the exact same thing, right? We built machine learning models to predict physical data, ran it around the basin, and then quantified, right, what's going on in each different area, where it works, where it doesn't, which intervals are good, which intervals are bad. We'll be doing the same exact thing, right? And you're going to see the exact same behavior like they were talking about, where I go up on the eastern shelf, I get up on the central basin platform, I get near a platform margin, right? You were in these meetings the last couple of days where you saw Pond and Ploy and they were struggling, right? To understand what's going on geologically. They're geologists and they don't know what's going on geologically, right? Scary. So, you know, the problem with that is that's where the models break down, because the geologist is breaking down too, right? They're like, fuck, I don't know what's going on here anymore. I got all my sequences, all the stuff that I'm looking at from the basin are gone. Now all of a sudden I have all these, you know, turbidites or high energy slope deposits or low energy slope deposits and fan systems, submarine fan systems, all this stuff, debrites, that are getting washed in, and the character changes completely. So from a pattern matching exercise standpoint, you can't do it anymore because my patterns are gone, right? And that's also when your machine learning models start to fail a bit, you know, because now all of a sudden they're trained to see a certain thing, and all of a sudden that changes. You know, like carbonate for me is typically micrite in a basin. That's what I'm trained on. All of a sudden now I've got debrites, right, and turbidites and stuff. Different type of lithology. Model log response is not the same. So, I suspect we'll see the exact same thing, right? Where it's able to predict facies, whatever machine learning model route we go down. It'll work pretty well in the basin center, but you know, these guys already picked up on it too. Like when you get to, you know, some of these other formations as well, is it appropriate to train a Sprayberry Trent model or Sprayberry Permian section model from, you know, the Clear Fork Shale down to the Strawn, which is all, you know, the stuff that we've been talking about. If you build a model on that, how representative is it of a dolomite reservoir? Not very, right? It's going to fail miserably. And that's why throughout petroleum geoscience, you know, carbonates and siliclastics are always sort of separated. Everything about them is different, right? How you classify, how you look at carbonate reservoirs, understand carbonate reservoirs, right? You know, even a classification, right? Dunham and all these different things that are used to describe rocks in general. You've got classification for siliclastics specifically. Then you've got like Jerry Lucia, who wrote that book and has all the papers and stuff on carbonates, right? Where you get into these things and, you know, it's a totally different system. You know, what's my primary porosity? What's my secondary porosity mechanism? Do I have bugs? Do I have this? Do I have that? Is there burrowing? Is there secrosic crystal overgrowth? Right? Is there not? Is there dissolution porosity? Is there not? Is it oolitic cemented grains? Is it not? Is there, you know, rootstone type reservoirs, or I've got, you know, crinoidal debris flows that are completely cemented up and then went through secondary diagenesis and hydrothermal dolomitization and wrench faulting. Like, did that happen or not? Right? That's the world of carbonates, and it can turn on a dime. You know, one area to the next can be very different. So, anyways, long story short, you know, we'll take the same approach that we did on the ML model. We'll just build it and we'll let her rip, and then quantify the mismatches. Where did it do good? Where did it do bad? Why is it doing bad? And if you're going to do models, how many models do you need? Right? I think a lot of the carbonate systems need to be lumped together, and then the shales need to be lumped together, and the silicoplastics need to be lumped together. You really need three different models, and maybe 4 or 5, considering the fact that some of the dolomites are, yeah, they're different, right? Like shallow dolomites versus really deep ones, like the Fosselman, Montoya, Ellenberger. Those things are total different beasts than the San Andres or Grayburg. Yeah, well, they do. You can, but then you lose accuracy, right? It's not as good. More generalized, it does the job, but it's not as precise. So, anyways, I guess get started on just kind of understanding what what we got in those WellCAD files, and then we'll work through this over the next couple of weeks, right? And we'll get it to the point where we get all the data together, and that's when the machine learning stuff happens. Yeah, well, yeah, you'll have to check them too, right? Like maybe the script is failing. Maybe there are logs. Maybe there isn't. I don't know. Like I haven't looked at any of this data, right? I have not looked at any of it. I don't know what's in those files. Couldn't tell you. All I know is that they're really fucking big, right? Each one of them is like 500 megabytes. And well, if you need to get an external hard drive or something, go buy one and just expense it, right? Yeah, you just go to Banana or whatever, and I'm sure there's that central there in Concan. Just go there and go to Banana and buy a Western Digital passport or whatever for 3,000 baht or whatever it is, right? Like 100 gig or 500 gigabyte or 1 terabyte drive should be enough. Yeah, 36 gigs, I think, right? Yeah. Like I said, I in that meeting, I worked a couple of those kind of closely, and I don't know what was going on. They didn't. It was almost worse than them. If they had never depth shifted at all, it would have been better. Whatever they did, just like really kind of uh, ruined the data. It's the only way that I can say it, right? Like it just screwed it up so badly that it was difficult for me to re-depth shift it. Like I'm trying to figure out the patterns and stuff, and I'm like, what the fuck? Why is it off depth 60 foot here, but it's like 0 foot here? Like somebody made bad mistakes when they did that, and they really complicated it. And the bad thing too is like people, for these consortia and stuff, all these oil companies paid money for that. And they're like using the data and stuff, and it's all off depth. So like I say, we'll find that stuff out once we get it loaded into IP and we start looking at it. You'll make a plot basically with like the mineralogy and stuff from the mineral solver, and you put the lithology from the the WellCAD file next to it, right? It should match. Like I've got carbonate here, I've got sandstone there. It should match, and that's what I found in the olivine. Is like I've got a big carbonate, but it was telling me it was shale or sandstone. What the fuck? It's because it's off depth because somebody came into work drunk or on drugs, right, and started working on the core. That's what happened. Yeah, well, and you know, the thing is, you think I'm joking, right? Like I had friends, I hung around with these guys. You know, like when I lived in Midland and I lived in Houston, I hung around with a couple of the people that worked for these labs, you know, and it's who do you think these guys are? You know, they're like geologists, or some of them aren't even geologists, you know, they're just like people off the street that got a job at the lab and they end up like, you know, running out to well sites and cutting the core with like a saw, you know, like taking it out of the barrels and shit. And they bring it back to the lab and they slab it, stuff like that. Or you know, they work their way up in the company. I had a buddy of mine, Matt, and then he was like kind of pissed off because they wouldn't promote him because he didn't have the right kind of college degree, right? But like this guy he would go smoke pot, you know, he'd get drunk all the time, like, and then go to work. And this is the guy that's doing the core descriptions and stuff, you know. It happens. Yeah, you know, so don't trust anything that you get with a lot of these. You just never know. You got to check it yourself. And to me, the check is because with the olivine, even the gamma ray, right? Like I put the gamma ray on there, it looked okay, but the lithology was completely wrong. Like they had entered the data incorrectly, is what they had done. And we needed to manually change it. So the two checks that we're going to have to look at is one is the gamma ray from the core, match the gamma ray from the logs. If it does, good, but that doesn't mean we're done yet. Does the lithology from the core match the lithology for mineral solver? If it does generally, and what you'd be looking at, again, it's like big, heavy areas where you've got giant carbonate. I know that should be limestone, right? So if it's telling me argillaceous siltstones or whatever, or telling me shale, organic shale, or something else, I know that I'm off depth. And then you have to flag the well the same as the olivine, and then go, you know, try to do whatever you can to fix it, which is not fun because this becomes a challenge. But you're one way or the other, you're going to learn all about the bad things that happen in the world of petrophysics. So this is it, you know. Oh no, and that's the thing too. Like, you know, when you get to really big companies, what ends up happening is you have this division of subject matter expertise. So you get all these guys that are experts. Most of them have PhDs, right? They're all doctors, like Exxon, Shell, Chevron, probably Tata to some extent as well. Uh, Saudi Aramco, you know, they've got all these guys, and these guys just do one little thing, you know, like there's a guy that does carbonates, but he doesn't do all carbonates. You know, he's not like the carbonate guy. He's just like the oolitic shoal guy, you know, at Shell. That's all he does. And if there's a project for an oolitic shoal, it goes to him and he works it. He knows everything there is to know about oolitic shoals. He's published 20 papers on it, right? Like Jeffrey Dravis or something like that. One of these guys that does the field trips in the Bahamas on oolitic shoals. But, you know, outside of that, they don't touch anything else. And whenever there's sort of any sort of integrated data, what ends up happening is nobody knows enough about anything else to even tell if it's good or bad. You know, because they're sitting in a specific standpoint. We're like, well, I don't know anything about logs. I never depth shifted a log. I'm the oolitic shoal guy, right? I know how to look at core. I know about lithology and depositional systems and cementing and diagenetic processes and, you know, modern depositional environment equivalents all over the world. I know all about the oolitic shoal reservoirs in the different parts of the world, but I know nothing about petrophysics. And, you know, so these things just kind of skirt by because of that. Where you get to the smaller companies and one person has to wear many hats. You know, they have many different jobs and responsibilities and things, and they pick up on this stuff really quickly. because they're like generalists, right? Not specialists. And they look at data and they say, oh, what the hell is that? Right? That doesn't make sense. Where the PhD never noticed, he's just like, I don't know. Looks good to me. I looked at the core description and the oolites are there just the way I expect them to be. Well, did you ever bother to look at the logs or well, why would I? I'm not a petrophysicist, right? It's not my job. So anyway, that's why you get what you get. So, Diamondback's really lean. There's only 2 petrophysicists that work for the whole company, and it's the same size as Oxy. Yeah. Only 2. They just hired a 3rd. Well, then you got us, right? Like I've been working for them for 5 years and I do a lot of the heavy lifting for them. But yeah. It was just 2 to begin with, Daniel and Doug, and then I started in 2020. I started 2021. I started working for them, and Sebastian got hired on after that. Then Sebastian quit, and then they're hiring this Beck guy. He's coming on, but major client. We do a lot of work for him. Tim, the guy that was there in that meeting, he's their Python guy, so we'll get his script and all that stuff as well that he wrote. But it's a huge opportunity here as well to kind of step into those shoes a bit, if interested, right, to provide services and things to the client. And then, if you can assume that role and live in there, if that's where you want to live, then, you work into an arrangement where you get the client to pay for you, right? That's the ideal situation. And say like, hey, you want this guy, you pay for him, right? Pay for him. I'll bill him to you, and then that's how we get you full-time position and pay you a bunch of money, right? That's how it works. Yeah, you got to seize the opportunity of being able to provide something that people need. You got to be that guy, right? And I'll tell you what, from a data science standpoint, there's 2 people that work for Diamondback, Tim and this girl, Corinne. Tim just quit. They hired another guy named Vincent Adams, who I know because I worked with him at Apache for years. And you've seen the movie The Matrix, right? Yeah, this guy looks just like Morpheus. I call him Morpheus. He looks exactly the same, right? But he's stepped into a data science role and he's pretty smart. But there's a huge gap at Diamondback in terms of data science, programming skills and stuff. And that's why I've been there for fucking 6 years now or whatever, right? As a client, basically working full time, is that nobody else can do the programming, nobody else. And it's not just doing programming, but it's knowing what to do, right? Having that subject matter expertise as a petroleum engineer, as a geologist, as a petrophysicist, and being able to write code. A programmer in and of itself is useless because they don't know anything about what we do. And, reservoir engineer in and of itself is useless if they can't code. But if you got both, you got value and it makes you exceptional, right? You can do what nobody else can do. So, that's job security as well. So absolutely, I think, from a career standpoint, you need to marry the 2. You can't just drop the petroleum stuff and say, I'm only going to do data science. But you also can't say, I'm only going to do that's why I push Pond and Ploy, and they still probably haven't done it yet. But I told them, they need to sign up for a Python class. They need to learn a little bit, because without that skill, it makes them very rigid, like how many people really want a geologist anymore or whatever? If that was their fate, I wouldn't want one. Now you give me a geologist that can write code, done, hired, right? But geologist that doesn't know anything about programming or Python or data analytics because just think about it. You work with data. All this stuff is giving you extra Harry Potter fucking magic power to work with data, right? You're able to plot it, manipulate it, do things with it, just like we're doing right now. If it wasn't for this, these guys would have to go into every single one of those 187 WellCAD files. And you heard Mike complain on the phone call about how he couldn't export all the data. He had to try multiple times, like one line at a time or something, one column at a time, because WellCAD doesn't let you like select all of the columns at once. You have to do one at a time, right? So you tell it, I want to export porosity, then I want to export XRD, then I want to export this and that. And because of that, you have to sit there and click on one well for like an hour to export everything, right? Right. Right. That's what that's what it comes down to. It's just having, extra power to solve problems and make life easier. And it doesn't require that you have a programming degree, and then you understand what semaphores are and, all that kind of stuff. All it requires is that you're able to pick up some basic, scripting and stuff like that and understand what's out there to use, to understand the different data packages and open source stuff that they have available, right? Different Anaconda or whatever the fuck it is, all these packages and stuff. Dash and Plotly and Matplotlib, like what these are, you know how to use them now. And really, when I was a student, everybody did this shit in MATLAB. That was the thing, right? You use MATLAB because you can plot, you can do calculus, you can do math in there, scientific engineering stuff. You can work with data sets because that's what every single engineer does, no matter what you are, mechanical, electrical, aeronautical, hydraulic, whatever kind of engineer. You get data from a laboratory or from testing, and then you interpret the data. And in order to interpret it, you got to make plots and charts, and you got to do math, right? And so MATLAB was it. Now Python is the new MATLAB. Yeah. Yep. Well, it's a nice thing too, because like when I had to learn everything in my career, I had nobody to help me. Zero, right? Nobody knew any of the stuff. There wasn't a single petrophysicist that I ever worked with that knew anything about how any of this stuff works. Like, how does mineral solver work? Nobody knew. We don't know. It's like some sort of inversion. You just put the stuff in and the answer comes out. Okay, let's like now you can sit down and you can work with an AI and say, explain to me how a stochastic linear inversion works. And it'll tell you exactly, right? This is how the system behaves. This is how it's solved.
Yeah.
This is where it could go wrong. And now all of a sudden, in 5 minutes of you talking with the AI, you're smarter than a guy that's been using the thing for 20 years, but never bothered to ask the questions or educate, right? Or learn about it.
Yeah. I think
Five
so.
minutes, and you're smarter than a guy that's been using something for 20 years. That's crazy to me.
Yeah.
But how many people are actually, doing that as well? Or, it's one of them things where people, I think you put them in a room, you put me in a room with anyone and argue with me or have a technical conversation. Everything's in my brain because I had to learn it. But I'm afraid that that's where we're going is, take away someone's phone, take away their chat GPT or their fucking Gemini and say, I want you to do something or I want you to explain something to me. And all of a sudden now, uh, I don't know. I have to ask the AI. I don't know. Normally I would ask the AI. And that's where you start to get into problems because the AI, and I've been using these things for at least probably not quite a year, but close now, and pushing them very, very hard, right?
Mm-hmm.
I have found that the AIs are miserable, if not awful, all of them, at any sort of design or architecture work, right? They can't figure anything out. Like you tell it, build a fucking, you know, uh, house for your cat to sleep in, or it doesn't know, right?
Yeah.
It just, how do I do that? But if you tell it, go get some wood, cut it into these pieces, glue it together this way, like, and you tell it step by step what it needs to do, it'll do it perfectly.
Yeah, it's
But it
about
just
the
can't
logic.
figure it out on
Yeah.
its own. Yeah, prompt engineering and all these things only go so far. I think right now at this point, these large language models are very effective at like doing things that would normally have taken us hours, like go through all these WellCAD files, right? Compile me summary statistics, clean this data up for me, you know, do very specific targeted programming tasks, you know, write me a control to graphically visualize XYZ, write me a function to implement a Rhapsod Newton iterative solver using Runga-Kutta, fourth order, right? Write that for me. You could be very specific. It goes and finds the textbooks and the different articles of papers and says, okay, Runga-Kutta fourth order. I'm doing, these sort of Riemann sums. I'm looking at this sort of fucking, derivative behavior on these sort of step sizes. This is how I converge. This is how I diverge. Blah 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 blah, and it can do it. Done. Now I've got a solver, right?
Mm.
Uh, but you ask it build a frac simulator. Doesn't
It
even fucking know where to begin, right?
it cannot.
Right. Anyhow, I'm gonna let you go play with the data. When you get LinkPad installed at some point, shoot me a note and I'll send you over a copy of that SQL database and we'll query that thing.
Okay.
And but first we're gonna need the spreadsheet from the WellCAD file. So you got to make that first before we do the second part. But all right,
Okay. Got it.
all right. Check in with you later.
Okay. Bye bye.
Yep. Bye bye.